Hi, everyone. I think we'll wait one more minute while people are joining. I still see some people coming into the meeting room, to the waiting room, and then we will get started.
It would be good if Zoom had waiting room music, so we didn't have to sit here in silence.
Ooh.
You could, if you'd like to make that happen, you could share music audio directly from your computer.
You don't want my music.
All right, I think we can get started. Let me see, yeah. So welcome everyone. For those who don't know or didn't make it to our workshop at CogSci, this virtual town hall is a follow-up. The workshop, and I guess, you know, by transitivity, this town hall are hosted by me. I'm Elisa Hlutsky, Matt Hardy, who you can see on the screen, and Bill Thompson, who else? I can't spotlight him, but he is in the chat and you can see his face there as well. And also Tom Griffiths, who unfortunately could not join today, but was a lovely moderator for the panel at the town hall. Yeah, so the goal of the workshop, for those who weren't there, was to try to ground the role of LLMs in cognitive science research, and conversely, ground the role of cognitive science in LLM research. So we basically wanted to get a better sense of what people are working on, try to lay some structure down for how we should be thinking about LLMs as the sort of deluge of new models comes out, paired with an even bigger deluge of new papers coming out. And I think sort of most importantly, perhaps, try to identify some exciting challenges and opportunities for what comes next. So for today's town hall, we're going to record it. We're going to post it on our website at cogsci.llm.com. You can find all of the speakers or panelists' talks recorded there as well. Hopefully you've already taken a look, but if not, feel free to go there after the town hall and take a look. If you have any questions throughout, please just write them in the chat. We're going to be posing some prepared questions to the panelists throughout. Then in the second half, we will take audience questions and then give them to the speakers as well. So anytime a question pops into your head, feel free to just send it to the chat. Okay, sweet. So without further ado, let's introduce our panelists. I'll let them introduce themselves. And I think I'll just call them out in order that they appear on my screen. So maybe first up, Taylor Webb, do you want to introduce yourself?
Sure. Hi, everybody. I'm Taylor. I'm a postdoc at UCLA in the psychology department. And I'm broadly interested in various topics at the intersection of AI and cognitive science. And so that involves both using AI systems as sort of cognitive models, but also taking inspiration from cognitive science to try to build better AI systems. And also, I think probably most relevant to this panel, trying to essentially perform cognitive evaluations of AI systems and try to evaluate their capacities using the methodology of cognitive science. And so in particular, the talk that I contributed is looking at the analogical reasoning ability of large language models. And yeah, looking forward to the discussion.
Awesome. Thanks, Taylor. And then up next, I have Anna on my screen.
Hi, my name is Anna or Anya. I'm a postdoc at MIT. I should be starting as a faculty member very soon, and as soon as the paperwork is finalized, I will post an actual announcement with the details of when and where and how. But for now, I'm at MIT. I did my PhD there also, looking at the relationship between language and thought, language and other cognitive functions in human brains, and now also in large language models. And for this workshop talk, I talked about the review position piece we put together on dissociating language and thought in LLMs with a few lovely co-authors, most notably my advisor, F. Fedorenko, and my co-lead, Karma Howald, who is a linguist at UT Austin.
Awesome, thanks, Anna. Up next, we have Ishita.
Hi, yeah, I'm a research scientist at DeepMind. I used to be physically in the new New York office, which opened just a couple of years ago. Just as of 2 months ago, I'm actually in the Mountain View area. So since the merge with Brain and DeepMind, there's a large presence in the Bay Area as well. So that's where I am right now. So my PhD was a lot of the work I did during my PhD was understanding human probabilistic inferences, as well as the kinds of, so basically trying to get a sense of how do they make, reasonably good decisions reasonably fast, but also the thing that I focused a lot on were actually the kinds of mistakes that they make, because there's only one right answer and there are a million wrong ones. So exactly which kind of wrong answer people give is very instructive to get a sense of what kinds of processing they're using. I also worked a bunch with the a little bit on the machine learning side, even earlier on, where basically trying to, things like compositionality, causality that have been studied extensively in the cognitive literature, trying to look for signatures of those kinds of things in machine learning models, even pre the LLM era. So since I joined DeepMind a couple of years ago and the language models started taking over, I've been working a lot with, the same kinds of things, looking at the mistakes that language models make, looking at whether we can find stamps of causality, compositionality in these kinds of systems. So just adapting a lot of those projects to this language model era. Very recently, as of just the last couple of months, I have joined not just the deluge of papers about language models, but new language models. So currently in the last couple of months, I've been working with helping build some of the new DeepMind language models. And that's also been a very interesting experience coming from the cognitive perspective. Happy to chat about any of that.
Super cool. Thanks, Ishita. Up next, we have Gary.
Hey, everyone. I'm a professor of psychology at University of Wisconsin-Madison. My main interest is in the cognitive functions of language and what does language do for us? What do we learn from language as people? And the connection to language models is they're this fascinating existence proof of what is in principle possible to learn from language. My work sort of spans, it's mostly experimental, but I've done a fair amount of neural net modeling in a connectionist tradition. I was a student of Jay McClellan's, and now getting back into it, looking at what these models are learning from language and how, and connecting it to experimental work that's been looking at the analogs in humans, in human language.
Thanks, Gary. Next, we have Robert.
Hi. I'm a new assistant professor also at the University of Wisconsin-Madison. Coincidentally, I think that I was tapped for this before I came here when I was formerly a postdoc in the same place as Ilya and Matt. I am broadly interested in the space where minds meet each other and interact with one another. So that often takes place through language in our everyday social interactions. And I've been very interested in models of adaptive language use. So the ability to change what you say, how you say it, depending on who you're talking to, depending on the context. Been very interested in the kind of pragmatics of language. So the way that we may enrich meaning or project our kind of goals into the language that we use with one another. So the talk that I contributed was a line of work with Taka Yamakoshi at UTokyo, who's been leading a number of projects trying to develop techniques for more surgical causal probing of language models, which I've been very excited about, to try to like look at the more like circuit level of exactly like what the processing streams are in language models.
Sweet, thanks, Robert. Up next, I have Sydney and Leo.
Okay, well, we could speak jointly as ourselves, but that would probably be less useful. I'm Leo. I'm a final year graduate student at MIT in BCS in Josh Tenenbaum's lab. I have a more computational background, so I was a computer scientist before I joined, but I'm in the cognitive science department now. Primarily what I'm interested in as far as language is concerned is how language actually relates to everything else that we seem to think about and talk about that isn't language. So the fact that we can talk pretty freely about physical objects in our environment and reason about them in ways that seem pretty related to the way that we reason about physical objects that we see. We can talk pretty generally about other agents and even what they believe and what they're going to do. We can form plans, and language that we hear impacts our plans. And certainly that seems to impact both how we learn in this very basic sense. If I tell you that it's, I saw that the grass is wet outside, it feels like you do something pretty intuitive to reason about whether or not it might be raining, but also in this much broader and richer sense that I think lots of us are interested in. It feels like that's how we learn fundamentally useful new sciences and teach each other about cognitive science and tell each other what large language models are. So the talk that I contributed is work that I led jointly with Gabe Grand, who's another graduate student, and also did with a bunch of other cognitive scientists here, most notably my advisor, Josh. And it was exploring how we might take the kinds of things that we're learning from large language models now, but actually integrate and think about how this like statistical information that is learned from language actually can be integrated and related to other kinds of models that we use to model those kinds of things like physics, social reasoning, theory of mind, rather than, I think, following the hypothesis that large language models certainly, I think, exemplify, which is attempting to learn those kinds of representations directly from the statistical structure of language. That I think is a really cool, interesting thing, but does not actually capture a lot of what we know, for example, from Anya's work about the relationship between language and these other parts of the human mind.
I'm Sydney. I have a background in psychology. I was trained as a developmental psychologist, actually. And then I did a postdoc here in Josh Tenenbaum's lab. But I was recently hired by the Allen Institute for Artificial Intelligence. So now I'm entirely surrounded by computer scientists. And my goal is to try to help build AI systems that make human-like moral judgments by drawing on what we know from the cognitive science of moral judgment. So the talk that I contributed actually kind of drew on the model that Leo and Gabe and Josh have been thinking about and applying it to this like really tricky domain of moral cognition, of moral judgment. And what I presented was a couple of very early attempts to use language models to translate from natural language into something else and then apply our kind of like very basic cognitive models to that representation to produce a moral judgment. But if you saw the talk, you know that there's like much more work to do to fulfill that vision. And so that's what we're kind of working on jointly together now. Not a coincidence that we're on the same screen. We just came from a meeting about that very thing. So.
Thank you both so much. And finally, we have Celeste.
Hi, I'm Celeste Kidd. I am faculty in psychology at UC Berkeley with Bill. My lab is generally interested in how people make up their minds, especially the part of the process where you're deciding what of all of the vast amounts of information in the world you want to pay attention to. Why do you pick these things and not others? Why is it the case that people sometimes don't change their mind in the way that you'd expect, even when they have a lot of good information in front of them? A lot of our work is about understanding the interaction between like what you think right now, your expectations, and then your interest in a particular piece of information. The talk that I contributed to the workshop was work with Abiba Bahrain, who is a Mozilla Fellow and faculty member at Trinity College Dublin. Her background is computer science, and she does a lot of like algorithmic auditing. She's popularly credited with the idea of large-scale language models as a way of like the relating colonialism to large-scale language models. Our work is about how when people are going to large-scale language models looking for answers, they're entering that moment open to learning, and that moment where they're open to learning is transient. And depending upon what comes out of the large-scale language model, we talk about the risk of the transmission of things like fabrications, or like sometimes called hallucinations, from these models to people, especially if they're communicated confidently, especially if it tends to have the same type of fabrication that happens across people. We also talked about how biases in these large-scale language models, due to a number of factors, only one of which is the training data set, also runs a risk of transmitting those biases to people. More recently, I've been interested in how kids are using large-scale language models, like ChatGPT, for things, and that's work that's in progress and planned with Bill.
All right, thanks everyone. Really great to hear everyone's intros. So it sounds like a lot of the speakers are thinking about LLMs in like a lot of different ways. So we sort of have this like alien intelligence concept that we treat, also that we treat our LLMs as kind of subjects in experiments and as models of human cognition, tools in research, and so on. So I think we're going to start with that kind of first idea of thinking of LLMs as this new form of intelligence, which we can like treat as a subject. So I'm curious what you guys think about treating LLMs as subject. Does this mean that we think about them in terms of intelligence in some way that's like qualitatively different than other models or people? And is treating them as subjects kind of the same as treating them as models, as in the language models? And how does that differ, and how are you thinking about that?
So I guess I'll start. So I tend to think about them not necessarily as subjects per se, but more as just kind of like a phenomenon. And I think whether they will be useful as cognitive models then depends on whether they show, interesting capacities in certain areas that we're interested in. And so in some cases, I think these systems really are showing capacities that seem relevant to understanding those capacities in humans. They're in some cases even making similar sorts of mistakes. And in those cases, I would say then that seems like a promising case where it might actually be useful as a model, especially if we can actually look inside of them and look for interesting hypotheses about the kinds of mechanisms that support those capacities. But then there might be other cases where maybe they have human-like capacities, but they seem to be doing it in a very different way than people. Maybe they don't make human-like errors. And in that case, I would think of it as just kind of like an interesting phenomenon, a different kind of intelligent system, which is, I would say, interesting in its own right, but then maybe not so useful for modeling human cognition.
Yeah. Related to like when you want to think of them as a subject, just recently actually in trying to do some of these cognitive-ish experiments on these language models, we were trying to figure out like how do you do a within subject or a between subject? Like what is the language model one subject? Like how do you what are the degrees of variation that you consider within a subject versus between a subject? How do you changing the prompt? Like where are the error bars? What do we average over to get a sense of like what is the same, the things that we use within cognitive science experimental design, like what are the analogs of that for a language model? And it was interesting. Like I don't have a good answer to that, but I think like various like it was interesting that I was thinking back to some of these previous studies of like sampling even within humans, that like these the crowd within type hypotheses, where like if you ask somebody a question 1 week and then you ask them the same question the next week, then the variance between them is more like a between subject variation than a within subject variation, where if you ask people the same question many times in a short period of time, then the answers they give are pretty similar. Whereas when they've lost the context of the experiment, then the answers they give can be quite different. And so just trying to get like, I don't, given the very different memory structures in these models, I don't really know what is a language, like given a specific prompt, like if you tell it to be a helpful teacher who is trying to help me solve this math problem, is it now that personality? Is that the subject I should treat it as? Versus if you ask it to be a interesting conversational partner who I met at a bar, is it that subject now? Like it's kind of interesting to think about what changes, like how does that map onto our notion of like, if you have a subject, then they have this sort of consistency.
Yeah, I think there are a few different questions here. So I think methodologically, there are a lot of parallels between how we would run an experiment on humans and on large language models. And, part of the reason why we're, as cognitive scientists, are all here is because our toolkit is actually well suited. We know how to design experiments, we know how to design controls. So it makes a lot of sense to evaluate the behavior of LLMs, other AI models, using our cognitive toolkit. Now, when we do that, we cannot assume that the model is solving the task in the same way that a human would. So there's lots of discussion happening now, right? Even if a model solves a cognitive test for humans, does not mean that it possesses the same cognitive ability. So that's an important caveat to keep in mind. And the other caveat that people are also starting to talk about is the fact that if you are trying to simulate human participants with large language models, you want to remember that it's going to be very culturally biased, that this model is trained mostly, the big models are trained mostly on English text from Western participants. And there is a great preprint on that I'm going to share in the chat.
I guess also building on what Anya just said, I think there are ways in which it seems like a lot of research that's happening right now, unfortunately, is in the position of acting as if these models are more like certain things that I associate with subjects, like not knowing their background, not really knowing who they are, treating them as largely anonymous. But actually my hope, I think, for certainly the like science of understanding what a large language model is, which I think is in some ways an AI question, but an AI question that has interesting implications for things like what Gary talked about. What is it that we can actually learn from language in principle? What information is generally contained in the statistics, not only of this like enormous amount of language that large language models are currently being trained on, but also perhaps things that look more like the data sets that kids actually learn language from. I mean, I think those are all interesting scientific questions. I think something that's I hope to see change moving forwards, and that I think is changing moving forwards, is there's a specific way in which I think a lot of cognitive scientists and also a lot of AI researchers are using large language models right now, which is acting as if this is not a controlled model, that we don't have access to the training data, that we are working with these models where we're also like conflating many different kinds of training objectives that originally came from training on the statistics of realistic language, but increasingly are being augmented with important but really different objectives that involve like doing reinforcement learning on particular kinds of prompts with underlying goals to produce specific kinds of language. All those things, like we would certainly pay attention if you were telling me that this was a subject that was raised in this very specific environment, unlike any other subject. But it seems like often we are running these kinds of experiments, on the one hand, treating it as if we want to say something about the distribution of language and what can we learn in principle from language. And yet, this very heterogeneous and kind of idiosyncratic background is largely what we're assuming. So I think that one of the like benefits of using these models is precisely that we have control of that language. We actually can ask these kinds of questions that we could never ask of a human child. And we can ask them in much more efficient ways. We can do things that are analogous to these twin studies and bilingual studies that we've always dreamt of running, and ask ourselves what kinds of syntactic features, for example, those kids learn. So I'm excited. I think that people are absolutely trying to do that, both in industry who have the capacity to train those kinds of models, and increasingly in academia. But I think to some sense, like one of the ways in which we're sort of sloppily using that language right now is actually because of something that we definitely can control, and that I think we will control in the future.
Yeah, just kind of picking up on that. So for those who don't know, the Allen Institute is starting to develop a completely open source language model, which will enable a lot of the experiments that Leo is pointing towards. But the other thing I would just say, picking up on what Anya brought up, is like I have a project currently going on with Max Kleiman-Weiner, who's on the call, and Zijing Jin, who is a student at ETH in Zurich, where we're specifically trying to figure out, well, who are these language models as subjects? What sorts of biases have they picked up? And we're developing this concept that we're calling an alignment map. So that is prompting the language model in different languages that come from different parts of the globe, and then figuring out, for people who actually come from that part of the globe, how does the language model, when it's prompted in their language, match the judgments that those people would give, and then just mapping it out on a literal global map, and asking how do models align with global populations. So that's, I mean, it's always something to keep in mind that the language models have certain biases, but we're also noticing, like, okay, we can start to figure out what those biases are.
Gary, I feel like I saw you strongly agreeing with a point a few minutes ago. Is there something you wanted to add there?
Yeah, I don't want to take up all the time kind of on a single question. So I can just say that one thing, so my contribution to this workshop is this little audio essay put together about the metaphors I've noticed people have been using for large language models, and my take on which ones I think are wrong, the kind of stochastic parrot, LLM as mimic metaphor, and the ones that seem to be more on the right track, where the model, in the course of lowering prediction error on large amounts of text, is learning something like a world model, which could be very different from people. And it doesn't mean that, of course, humans learn world models in that same way from language, but that there is more there than what is literally kind of in the language, right? So, there's a question, right, about could these differences in language experience across groups, right? It's a linguistic relativity question, mirror the kind of biases that people learn, and that can give insights into the nature of cross-cultural and cross-linguistic differences. We have much better models of people's linguistic experience, even though it is still largely restricted to written language, which of course leaves out many languages. But we still have better models of that than of people's kind of actual world experience, right? How do you even begin to model, right, the world experience of a French speaker versus an English speaker versus a Hausa speaker, in the world itself. But I also think, and this goes back to something that was discussed at the Philosophy of Deep Learning conference last spring, right, where we don't quite have the vocabulary to think about whether a model, it's not quite a participant. It's also not quite a group, right? You can ask a question of a group, right, and average across, right? It's not quite that. And I think there's some conceptual engineering to be done, right, with how to think of what where a trained model is in this space.
I want to send the next question related to these topics to Celeste, specifically about this idea that Sydney and Gary both talked about, and then a few other of our speakers, that our LLMs are forming these sort of maybe brittle world-ish models. We're using LLMs as participants sometimes. Sometimes we're using them as models of human cognition. Sometimes we're now using them to just replace human ratings for a lot of things. What are the risks that come from that? So what are you and your collaborators finding are, aside from bias,
right,
which is the big one we talk about, what else sort of can we expect?
Yeah, I like what Gary said about it being difficult to find exactly the right metaphor. Like stochastic parrots is not quite right. It's doing something that is like yeah, not exactly the same thing as mimicry, but also is not, it's the idea that a lot of developers have espoused when talking about these things is it's a concatenation of like all of human knowledge, as like it's something that is super intelligent. It's not everything altogether. And the fact that we don't quite have a handle, we don't have a good metaphor that perfectly encapsulates what it's doing, I think is part of the difficulty in like knowing how to interpret the outputs. There's some work by Leonardo Nicoletti, who's a reporter from Bloomberg, on biases in a very different type of model, in a text-to-image model, the Stable Diffusion model, showing how that model, despite the fact that the Stable Diffusion model is not using reinforcement learning with human feedback, which is one possible source for like amplifying biases because the way we incentivize people to give the feedback, the biases in those models get exaggerated beyond what's true of real world data and beyond what's even true of the training data set in some cases. If you ask the Stable Diffusion model to generate an image of an inmate, it generates a blackface 80% of the time, even though most inmates in the US are white. Overwhelmingly they're white. So there's the amplifying the stereotypes, but I think when we're talking about language, there's something else there, which is like any query that you are putting into the system has semantic information. It means something, but there's also like quite a bit about language that is encoding other facts that are not facts about the world, that are facts about the speaker identity, things that people, things in language encode things about gender, age, geographic region. Like this is less obvious in text-based models and more obvious in the spoken language models. But those identity features are also something that we are finding makes a difference in terms of what the model gives you back. It does not give the same information to somebody that is asking, requesting information in a standard American dialect versus like an Appalachian dialect. There are inequities in terms of what information people get back. Keeping that in mind when using these things as, a stand-in for like a participant, that's something important to keep in mind, but also being skeptical of the proposed applications of large-scale language models for creating equity and giving everybody equal access to information. The proposals for using this as the backend for ed tech, I think, are really problematic, given this fact about them. So yeah, that was a lot and only part of the answer to your question.
Yeah, I might chime in on that as well. I really liked all of the points you were making, Celeste, and I think that particularly this question of like, sociolinguistic variation is something that, as scientists, we talk to different people different ways, and that's often using either meta textual information, so extra textual information about the background of who we're talking to, the context in which we're talking to them, right? Like, are they in a lecture hall, or are they like in our living room, or something? And I think that there's a really important question about like when you strip away all of that scaffolding that we use to adapt our language, what do you end up with? And I guess, you know, in principle, like some variation like that is desirable, where, you know, if I'm an expert in say a number of people use GPT for coding assistance or something. So like, say I'm a software developer that's like 20 years into my career, the kind of level at which my questions are being asked and the kinds of things that would be helpful to me are going to be different than a first year, you know, computer science major that's just trying to get in to it. And that's even different than someone who, you know, may not have any kind of formal education background at all, but is still trying to like build something. And I think that like understanding, so this is maybe where like understanding the way that human language is adaptive may help us understand like the right way to be adaptive and the, you know, the risk, because like obviously, you know, humans can be extremely condescending and extremely racist and extremely sexist and extremely you know, not helpful interlocutors all the time. So I think that, you know, that's also a differentiation between like, what are we looking to these models to do? If I'm looking at this from a sociolinguistic, you know, point of view, I'm interested in those kinds of human biases. But if we're deploying it for public use, then, you know, you want it to do something a little different. So I think that those are kind of like interesting axes of inquiry.
So Celeste, I wanted to quickly ask, in your talk, you mentioned people using and relying on various cues to confidence, right, to assess, right, you know, how confident the speaker is. It's an important source of information. At least the public-facing LLMs, perhaps because they were rewarded to be confident, right? Like, why would you rate a response saying, well, maybe, you know, as very good, right? Are overly confident. But that seems like not an in principle problem, right? So, you know, probability is at the very heart of the model. So modulating the response or informing the response by some more continuous probability function seems like well within you know, what these models can do. So unlike, for example, evidence that the models in some cases are magnifying the biases present in the training data, the issue of overconfidence and kind of inappropriately signaling, you know, using very confident assertive language, what is actually kind of potentially contentious, right? Like those two seem to be different sorts of problems.
Absolutely. And that thing you said about like, to what degree is this a problem? I think it really depends on some things that we don't know yet, which is how users are conceptualizing the model. I was like, if you're aware that these are models that get things wrong sometimes, but say stuff confidently, like maybe it doesn't throw you off that much and it's not a problem. I strongly suspect, based on just some pilot data that we have, that's not like we are aware about how these things work more than the average person. My dad, if ChatGPT tells him something with confidence, it's true, and he'll say like, I didn't know that, I really thought it was something different, even when it's something that's in his wheelhouse. He has such a strong belief that this represents a concatenation of human knowledge. That's what it is in his head. He's bought what people like Sam Altman have said. If you come in with that strong belief first, and then you have the you know, the output taking the form that it does, without any indicators of uncertainty, it impacts you very differently. But it's absolutely different from the bias issue. I said me and Abiba wrote in the paper, and then I can't remember if this made it into the talk, but this is very different than a person learning from another person, where people literally cannot entirely obscure many indicators of their uncertainty. People have things like a response latency. It takes you longer to compose something that you're less sure of than something that you're very confident about. If you're asked for directions and it's a direction that you know, that comes out quicker than one that you're less sure of. People have unsuppressible signals that they use to communicate with one another that they both put out there, but then also people are sensitive to, they can make use of those cues where these large scale language models, the text outputs don't have that. And so it's I think it's an open question how big of a problem that is. It's going to depend upon the person's conceptualization, but it's something, separate from bias that we should be worried about.
It's two sub-issues, right? It's one is signaling uncertainty, which humans do, and the other one is meta-awareness of your own uncertainty. And it seems like LLMs are bad at assessing their own uncertainty, which we can modulate how they express themselves. But a lot of the time, from what I've heard, it's one of the reasons why in practical applications, companies can't really use LLMs right now, even if the model is right 95% of the time and wrong 5% of the time, or doesn't know 5% of the time. It can just say, oh, I don't know, I need a human here. It will constantly say something, even if it's not correct.
Yeah, that all sounds right. The lack of an uncertainty signal as an intrinsic part of the model. I was like, when Gary mentioned some efforts to like try to moderate that, I was like, I've seen a lot of efforts to try to figure out how you can add something on top of the output to a large scale language model to get a rating on how trustworthy this is. But that's not easily scalable. It's not a great, I don't have a lot of confidence in that as a solution.
So maybe building on that a little bit, I want to throw the next question to Leo and then Ishita. When it comes to actually deploying these models, what can we do today? What is safe? What applications can we build? How can we include them as components in larger systems? What are you seeing in your work that actually is working these days?
Yeah, I was just gonna say, definitely don't ask me about what should be deployed. Ask Ishita. But I think that maybe to build on this question about what biases do people bring to the table? I think a lot of the work that we presented in this talk and are doing this paper just tries to consider ways in which I think it's both scientifically useful to ask one kind of question, right? Regardless of what particular architecture we're using right now, we can still think about the language modeling objective, right? What actually would it mean to build a perfect Oracle language model? I think that I was just scrolling through that post that somebody posted in the chat and that Gary was mentioning, and a lot of that argument, I think, is an argument that is fascinating in AI for a reason, because it does feel plausible and interesting to consider that what it would really mean to build this perfect model that can have arbitrary English sentences, or maybe even arbitrary English sentences at the scale of the ones that, and the breadth of the ones that are available, say, on the human internet today, and that could actually answer those in a way that another human being would, that would be a very intelligent architecture. On the other hand, I think there is an empirical question that is in some ways a very forward-looking question, right? We're all interested in language models, not just because what language models do right now, but because what we imagine and hope might either happen if we continue to scale directly on this route, which looks largely like trying to find more data and sticking with the architecture that we have, versus whether there are going to be seams in that approach that's of interest to cognitive scientists and AI researchers that would in some ways require us to shift how we think about those architectures and think about what more might be needed. And so one thing to say about the current staying the root idea is this quote that I have been saying with, or repeating and talking about with some of my friends. We recently had somebody who works on one of the large language model teams at one of the big companies, I won't say which, and who plays a pretty leading role there, talk about this new challenge that everyone is interested in, trying to get large language models to expand the length of the language that they can understand. who wouldn't want to be interested in a language model that can read a novel and learn from it, read a textbook and learn from it? And something funny that he said, just as a matter of fact, is, but that's a problem because there was a lot of text on the short length text on the internet, but there just aren't enough novels in the world. And we were laughing because we were saying, no human being has ever said there aren't enough novels in the world to learn how to understand a novel. And of course, I think we all acknowledge that that's because language models are starting from a really different place than we are. And so without, I think, answering this question of what are going to be the bets that are going to bring us forward in the future, what a lot of our work tries to look at is to say, okay, well, but what kinds of what inspiration can we take from how, an architecture that is clearly different from a language model, a person might actually be using, in which the language part of our brain that thinks about language is just so much smaller and related to all these other things that we use to solve all these analogous problems in the world, like thinking about other social agents, like thinking about physics. And in the here and now, right, like we have actually spent years building up these kinds of other AI toolkits to solve these other kinds of problems. That is what the domain of thinking about building agents that plan and move in the world is supposed to work on. That is what all of these software engineering systems that are supposed to handle modeling and simulating the world are working on. And I think that what's unifying across these themes is something that I don't think is just something we're saying. I saw this talk from Dan Klein, who's a NLP researcher at Berkeley, and he said this really nice thing that I think was like, in nowhere in history has the future of software engineering for robust and safe software engineering looked like trying to figure out how to work with a system where the way that you program it or specify what task you want it to solve is figuring out the magic words to say. That's not what we associate with a good software engineering system. It looks like breaking things down into modular and controllable systems. And perhaps in the future, those will look like some other thing that is more closely related to large language models. Maybe that thing will look closer to what is more like today's programming languages. Maybe it will look like developing programming languages that we're confident can formally specify the mechanisms and that we've determined can specify the mechanisms of language models. But I do think that those principles of software engineering, which is a lot of how I think our work tries to think about reverse engineering the human mind, are also going to continue to be useful in how we think about building AIs, compositionality, modularity, verification. And that's not a specific set of components you plug in. I think those are principles for software engineering.
Yeah, absolutely. Thanks, Leah. That was really, I think one of the things that's been front and center in my thoughts of the last few months has been, like, we spoke a little bit about the sociological context of like language models entering the broader society, but I feel like there's also, for me, coming from a more cognitive perspective, I feel like I've been exposed to the sociological setting that leads to these models being built and released. So I think that's also just been kind of an interesting exposure of like, how do you sort of interface with the folks who want to release the next big model to convince them of like how to like, what are the interesting questions that might be interesting from a different perspective, which isn't necessarily like going on the train of just the larger models getting larger data. And I think it's a pretty difficult conversation. I mean, it's interesting that given the successes that method has had, there's a sort of hubris that is a little difficult to overcome. And, so it's kind of been interesting to figure out how within the metrics and the ways in which these teams and models and, these research programs operate, how do you insert concern at the level that sounds like, that where you also provide some sort of path to a solution. It's kind of interesting where like people are more receptive if it's incremental versus if you're suggesting something that's radically different. So I think that's been a kind of interesting experience of trying to get a sense of like, so for example, a lot of the work that I do within this larger team building these models is on evaluations. So that's something that you can clearly demonstrate that like I'm using your model and I'm using these different methods for evaluation. And you can show that if I add this kind of training data or this kind of this kind of iterative like self-reflection loop or whatever, like some kind of method which changes this metric, then it's like, being able to find that thing where you can actually get a signal for some kind of improvement or some kind of change in the direction you want to argue for has been a sort of interesting, that it feels like that's the thing that works the best in terms of actually trying to start steering that ship. From inside, I think like there are obviously like proofs of concept where you want it to be drastically different, so you can point to that as well, as a goal or as a direction to move towards. So I think the like more in terms of like, yeah, reflecting these comments on like breaking a lot of the assumptions of reliability and software engineering, unit testing and things like that. That's obviously been also very real within the companies, because I think most of the folks releasing these models come from that background. Like they're used to the idea of being able to, say for sure what they're releasing. So I wouldn't say that people are, even folks releasing it are very awkward and uncomfortable about the fact that, at least at the engineering level. Like I don't know about the folks actually making the decisions. So that's also just been really like, adapting those frameworks. I think there's a lot of interesting work to be done of adapting those frameworks for reliability in a setting where you don't actually have access to it's not a white box system. So how do you, I don't really know whether it's even possible or whether you just need to start from scratch.
And I just point out, there's something really ironic, right, about this kind of clash of metaphors, right? So we are totally used to people being unreliable, right? If you ask someone to count characters in a sentence and they're off by a few, you're not like, oh, I guess you're not really intelligent after all, right? But you don't expect a computer to make a mistake of this sort, right? I search for string in a corpus. It tells me if that string occurs or not with absolute certainty, right? We come to expect that from, our mental model of computers. And so this breaks that model, right? And hence the huge confusion on part of the public is, how is it being so smart here, but it's failing simple arithmetic? And ironically, that's actually the pattern you, maybe Anya would disagree, that is more appropriate for human intelligence, right? It's good at synthesis. It's bad at arithmetic. That's why we have calculators, right?
Maybe on that note too, I think that there's a really interesting connection to, like Lorraine Deston wrote this interesting history of rules. And a lot of it is kind of a history of like the way algorithms have kind of become our model for precise rules that are deterministic and carried out the same way, no matter where and when they're executed. And she was pointing out that earlier in kind of like, I guess, Benedictine abbeys and things, there was like the notion of a rule was like always was like a thick rule as opposed to like a thin rule. So it's this rules always come with exceptions and like come with discretion, which is to say like the abbey leader could override something if they kind of there was like a rule that says like no one's allowed to enter the abbey except for this particular case, and then the leader could look at it and be like, well, maybe we'll also like include this other case. And I think that like that breaking our kind of metaphor of thin rules, very tied up in industrial capitalism and the need for like uniformity in factories and so forth, like I think does really challenge what we expect, and I think is like really difficult because I don't think we want to like cede the power. So like the whole point of having thick rules was that someone with like that the community trusts as like a voice or a leader to kind of use discretion. And I think that like the idea of ceding that kind of leadership role to a black box system, I think is maybe something to think about if that's our new model of what computers do.
So maybe building on that. Sorry, did I interrupt you? Should I? If you
no, sorry. Just like a minor, like I think this is more of a, I think I recognize that I think a lot of the places in which this clash also comes into the fore is also given that there are still humans that have to justify what this language model said. Like there's some engineer who's responsible, who's the site reliability engineer for making sure that this doesn't mess up or doesn't do something dumb. Whereas now there's another person who's responsible for the mistakes of this language model that is being released. So I think that's a lot of the places where the anxiety comes from, where like, if you're releasing something that there's a sort of a belief from this like product perspective that, like this is going to work the way you expect. And if it doesn't, I'm going to file a bug report and it's going to be fixed. Whereas now, that paradigm just doesn't work anymore. So that's kind of like, yeah, I don't know, like there's a, I think more from the folks who are having to like deal with the people being unhappy with the way that something might work. So I think that's been causing, like I think I'm not really sure what the easiest way is going to be of like whether it's just going to be changing expectations from users or whether there's going to be something from the people releasing these models that can actually promise that, okay, we will ensure that it doesn't do that again.
That's a super interesting point. I have a follow-up question, which is, do you think that it's not intuitive what exactly large-scale language models are doing? I was like, I think that there's another like common misconception, which is it really feels like it's speaking with one voice. I was like, there's been a lot of fine tuning of it to make it sound like it's speaking with one voice, like it's one entity, when really I was like, it's clearly referencing different pieces of a training data set depending upon what topic you're talking about. You can get it into a kind of like sci-fi movie mode where it's using very different language than when you're talking about another topic. It can adjust so that it's talking in a way that's appropriate to a kid. Inferring what it's doing behind the scenes is hard, even for scientists that know a lot about the possibilities. What are the chances that like people are gonna converge on something reasonable, especially in light of like how much it's not just like the large scale language models, a lot of them have undergone like quite a lot of like semi-scripting, fine-tuning, adding guardrails, is like adding a calculator. That makes it even harder to figure out what they can be trusted for and what they can't. Yeah. Do you think people will? I think there's no hope of people like eventually updating and having an accurate representation. But the pressure of the person being responsible for the errors is a super, super interesting point and pressure on where these things go and what shapes them that I hadn't appreciated until you made that point. It's super, super cool.
Yeah, absolutely. And I think, I mean, just a minor addition of like, the point you made, Celeste, that like, even the concept of filing the right bug report doesn't exist. Like even as a user, how do I describe what exactly it did? Because in one situation, it did something weird in one particular way, but did something else weird in another particular way. But yeah, like I think, TBD.
Yeah.
But can I just add something on this question of like trustworthiness and errors? So I think sort of picking up on Gary's point, it certainly does seem to be the case that in lots of instances, the errors that these systems make are very human-like, which I think is very interesting from a cognitive perspective. But I think in some sense, they're errors that people tend to make when they're not being particularly reflective and when they're just trying to answer a question quickly, system one, automatic sorts of things. I think people, of course, do also, in some cases, are able to go into this more reflective mode where they're actually thinking more systematically and are less susceptible to underlying statistics. And I think, of course, currently people are really trying to figure out how to get that more reflective sort of system two, so to speak, processing into these systems. And so things like, chain of thought, all of these various language model architectures are sort of starting to go in that direction. But I think, maybe trying to build in a more sort of like internal recurrent processing that's not, based on this sort of external linguistic train is probably going to be an important step in that direction, I think.
I love this topic. And yeah, HT also mentioned it right in the introduction, figuring out what mistakes these models make and why, and are they similar to the ones humans make. And I think Gary is right, and I appreciate you pushing this point forward in the public discourse that, we shouldn't just always assume perfect behavior in models, even if mistakes can arise frequently in humans, and also you should just work on content effects in reasoning in these models that are human-like is a good example of that. But I think we should distinguish between different kinds of errors that humans make, because sometimes the kinds of errors and deviation patterns are actually indicative of the mechanism by which this function is being carried out, right? So if it's really at the heart of the computation, then you would expect humans and models to make the same mistakes. If the model is making different mistakes, well, it doesn't really have that computational capacity, it's doing something different. But sometimes there are errors humans make because it's multiple mechanisms interacting. There's the capacity that we're interested in, and people not paying attention, not being motivated, and all kinds of external factors that might affect performance, or I don't know, misspelling things. And I don't think we would want AI systems to have these kind of errors. If anything, we would want them to minimize this kind of issues in machines. So I don't think just because humans make that mistake means that it's okay for an AI system to do so.
Yeah, I mean, I absolutely agree. I think that but I think, yeah, it comes back to the question of do we treat them as subjects or do we treat them as humans? And I feel like currently both people's expectations as well as I think people just don't know how to interact with them yet. I think if you expect you're interacting with the computer, then you expect certain kinds of errors and are less forgiving of certain kinds of errors, or, you have a certain model going into that interaction. Whereas I think currently people, given their fluency, people assume I think that depending on the situation, sometimes they expect a computer and sometimes they expect a person, and it's just what is surprising or what is reasonable to expect in those situations are very different. Yeah, I have to hop off, but it was really nice seeing all of you and chatting. This was super interesting.
Thanks, Ishita. With that, I think we want to get to some of the questions that our audience members posed, since we're getting towards the end of the workshop. And I think one of the questions we got a lot when people were registering for the event in various forms was, at the end of the day, LLMs seem to be just predicting the next token. What can we really learn about human cognition or about brains or about language just by predicting the next token very well? I'll open that to all four of you.
Yeah, I think others have already noted this in our discussion, but I think personally, I feel that's not really literally their training objective is to predict the next token. So that is the case, but I think it is somewhat misleading to think of them as only predicting the next token. And I think others have made this point that in order to really, I think Leo made this point, in order to truly perfectly predict the next token, that basically necessarily involves being very intelligent, having good world models, reasoning, and so on. And so I think a better way to think about what they're doing is that in the process of learning to predict the next token, they've sort of induced something that approximates world models in some cases, not so well in other cases. But in principle, that's the possibility here. And in some cases, it doesn't work well. And in those cases, they're actually not very good at predicting the next token, right? So I think, yeah, that's maybe something that's going on under the hood that makes this more of an interesting system to study.
I think it's fascinating to see the patterns of successes and failures, right? And so it's interesting that you can learn some semblance of a physical world model from language, but despite the enormous parameter counts and corpus size, still get simple arithmetic wrong, right? And it tells us about more versus less effective ways, possibly, of training humans to do things, right? So it's not a coincidence, it seems, that humans obviously learn physical world models without much help from language, right? If you're predicting if something is going to fall, you're probably not using language to any significant degree. But humans aren't, also learning arithmetic. That requires deliberate formal training, teaching kids how to execute an algorithm. Even then it's quite difficult without such an algorithm, without using external resources like pen and paper. It becomes pretty much impossible. So it has something to teach us there about what is in principle possible to learn through predicting text. And I've also noticed this, Taylor, very much along the lines of what you're saying. There's a general confusion between the learning algorithm, the learning objective, right, and the learned algorithm. So in order to get good at prediction, you need to learn more abstract models. And this is not just true of predicting words, it's also true of predicting sensory data. We are, I think, prediction machines, right? And so in lowering sensory prediction error, we learn more complex and less brittle world models, right? So it's to me, it sort of vindicates the power of simple predictive learning mechanisms in general.
Yeah, I agree. And yeah, Gary, in your other essay, you end with the metaphor of the LLMs as pattern machines. And I like that one a lot. And there's some interesting work. I'm going to share an example that, I don't know, appealed to me as a proof of principle, that in order to predict the next word, the next token, you need to learn patterns of certain kinds, of many different kinds. And so there's evidence that over the course of the training, models first pick up on very common patterns, right? Like something very basic that you see on the web a lot of the time. And it looks like a lot of that is actually grammar. And so that's why we think large language models might be good at what we call formal linguistic competence. So knowing the rules and patterns of language, it turns out that knowing that he is and not he are is just a very common pattern that will help you predict a lot of things a lot of the time. And then as you start training the model more and more, it will start picking up on less common and more subtle patterns, maybe from domain-specific reasoning, like certain kinds of math. And then there is a question of like, okay, at some point patterns will not suffice, right? And at some point, maybe if you come to algorithmic thinking, it really cannot be approximated well enough with pattern matching. And so there might be some fundamental limits of these models that arise exactly from the fact that they are pattern machines.
Well, just to add to that, I think one of the interesting questions is exactly what the fundamental limits are. And I think, as Gary noted, there's the training algorithm that's used to train these systems, but then there's algorithms that they learn in some sense, both in terms of like the actual internal circuits that arise over the course of learning, but also these days, my understanding is that people are training these systems actually on sort of chain of thought trains. And so you can think about that as there's almost a different algorithm that's being implemented at the level of those sort of chains of natural language. And, in that case, to me, that seems almost like a separate system that might have different sorts of emergent capabilities beyond the sort of like basic pattern matching capabilities of the, the way the network is trained. And so, yeah, I mean, I wouldn't make any strong claims about that, but to me, it seems like it's very much an open question, like exactly how far that sort of thing can be pushed.
So Celeste, I'm not sure if you want to share thoughts on that, but I'll pose the follow-up question we have from the audience to you, which is, it seems like we are able to learn about human cognition by studying LLMs. But what's going to be the impact of LLMs on human cognition? So, for example, what will happen as misinformation is being generated by LLMs? What happens as we start to rely on LLMs more as tools? How does that impact our cognition, or how do you think it might impact our cognition?
So I didn't answer the last question on purpose because I thought Gary did a really good job of the caveat of like it tells us something about like how things could be learned in theory. I guess I'm a little bit more skeptical than I think other people on the panel in terms of like how much that tells us. It's different. It's different from what a person is doing. I think it definitely is useful in all the ways that everybody said. In terms of like how it impacts humans learning and humans interactions, the science piece with Abiba Brain lays out like some of the like top reasons for concern, and a lot of it really hinges on information that we don't have yet about many of the things people have brought up around uncertainty and how people are conceptualizing these systems. Here are some things that are like useful to know for considering that question. Work by Lisa Fazio shows that even when you know that something is not true, if you are repeatedly exposed to it, if you hear it over and over again, your estimate of how likely it is to be true still goes up, even if you started out by saying like, I know that's not right. It seems more likely, and this is an unconscious process. As people are going to these systems for answering questions, as it seems to be the case that kids are probably doing, according to the Common Sense Media data on this subject, if it's replacing basic search for kids, and it's delivering information in a way that they perceive to be confident, which, yeah, all of Gary's points, like we don't know if that's what they're doing, it runs the risk of diminishing their curiosity about the particular question they went to it with, because it gives a little satisfying nugget of exactly what you were looking for. And that could have a lot of unintended consequences. Usually in the world, when you have a big question, you want to learn about a topic, it's actually pretty hard to get information on exactly what you want to know. What happens when you're trying to learn something new is usually you like get other information that's not quite what you were looking for, that opens up new questions, and that's how curiosity is fed. As like you develop new questions that you didn't have at the beginning, in part because you're maintaining a lot of uncertainty about your initial question, but then all the things surrounding it. If you have a system that gives kids the answers to exactly and only the question that they want an answer to, it's possible, this is all super theoretical, we don't know, I was like, we need to do work on this, that could have the effect of being very gratifying. I was like, it's exactly what you wanted, but it could cause curiosity to plummet. It could deplete interest in exploring the topic more broadly. It feels really good is probably why kids are using it. I was like, it's a dream to know exactly, like, I want to know this thing, I want to know just this thing. But like actually in having a system that indulges that urge might have unintended consequences in terms of kids not exploring as broadly as they would if they were getting less perfect of a response to what they were interested in. So yeah, these are open questions, how it's gonna impact people, but as like especially kids that know less about the world in general.
Anna, Taylor, or Gary, did any of you want to follow up? Any additional thoughts on that question? If not, then I want to get one more audience question that we had a lot of audience members asking again in the registration form before we wrap up, which is sort of a little bit of a meta question or a personal question in the sense of how do you actually go about studying, doing research at the intersection of cognitive science, neuroscience, linguistics, and with LLMs, especially with sort of the high pace that we're seeing, the crazy high pace of new technology coming out, but also thousands and thousands of new studies coming out. So in particular, we had questions from our students who were saying, how do you deal with the pace? How do you deal with potentially getting scooped? How do you find creative, interesting niches to work on and try to make an impact?
I think another way of phrasing that too is like, do you approach this differently than your other projects, or do you think the best move is to just treat your LLM, generative AI projects the way you treat your, more traditional projects?
I could start by saying like, I'm definitely not treating them the same. I was like, there's much more of a pressure to like go fast, and also like go fast, but without resources. So that some of the stuff that I'm talking about, like we want to do, we figured out a good way of doing. I applied for traditional grants, and even the ones that are like foundations where I'm going to hear back in a month, I'm like, that's actually not fast enough. Like I'm trying to get resources together quicker, and that's different from the other research. There's a lot of the companies that have developed LLMs are very open to working with researchers and providing the resources for it, but that of course creates a conflict. So I haven't wanted to do that. I'm not touching that as an option, even though we could go quicker because, yeah, I think for obvious conflict reasons. But yeah, I'm interested in hearing other people's thoughts. That's an awesome question.
I'm glad I'm not a grad student in computer science, machine learning. But I think a lot of the papers are focused more on beating the state of the art, right? On improving on benchmarks, and the pace. When it comes to papers that are trying to kind of get a better understanding of the mechanisms, better conceptual understanding, it's still rapid, but it's not nearly as rapid. And so for me, it's been a lot of watching the literature, watching the preprints, noticing, where a new result strongly violates my expectations, right? It's like, oh, wow, I really wouldn't have expected, that it could do this or that it would fail on it. One specific project we've been working on for a while now, just kind of put it on the back burner and just picked it back up, is trying to understand how these models represent and the difference between principled versus statistical relationships, so that airplanes have wings by virtue of being an airplane, but airplanes have passengers. Yes, that's true, but you could have an airplane without passengers. It's still a perfectly fine airplane. Kids are very sensitive to this. Adults are very sensitive to it. And these models are not until GPT-4. And then it basically has a 0.8 correlation with human judgments, controlling for everything. Now, unfortunately, so that's cool. It's like, okay, well, that's, seems like it is in principle learnable from the input. But of course, OpenAI provides no information on what is different in the training data, for example, of GPT-4 compared to 3.5. And so it's frustrating to not be able to answer that kind of question. Now, I should point out that when it comes to testing human participants, we also have limited access to, a subject comes in, you test them, you don't know what their past experience is. We have maybe better ideas, but like it's still unknown and in some of the same ways, and we get by, right? We figure out clever ways of asking these kinds of developmental questions, right, without having access to all the training experience that a subject of a certain age, let's say, received. But not having access to this kind of basic information is problematic.
So I'll just say, first of all, I completely share the sense of being overwhelmed by the pace of things. But I think sort of echoing what Gary said, the pace seems to be especially accelerated in like the development of systems and pushing the state of the art forward. I think it's maybe like a tad bit slower for like cognitive evaluations of these systems. And that's something where I think people from a cognitive science background can obviously be very useful. And in terms of, how to pick something where you're not going to be scooped like a few months later, I think, basically trying to focus on areas of expertise that you already have and what can you uniquely bring to a problem? What topics do you know about that might make you uniquely qualified to try to interrogate these systems? I think that's probably going to be the best bet, and that's the approach I've taken.
Yeah, lots of great and interesting questions. I have personally found refuge from the crazy pace in switching between AI and neuroscience projects, right? Compared to AI, neuroscience, we have a paper come out like every, there's stuff happening, but like things you really have to pay attention to, the pace is just not nearly the same. So it's been nice to be able to do something that is just not as crazy fast. So maybe if you can find a kind of balance like that, that could work. But another thing that's just different about working on large language models is this increased sense of responsibility, right? There are people outside of academia that suddenly really care about your work, and it gets public coverage, and journalists come and ask you questions, and there's so much hype and so much misinformation. And so I think, I don't know, I felt a lot more responsibility as a scientist when talking about large language model research. And we are very well positioned to dispel some of the myths. We can talk about a lot of issues and cognitive distortions that humans might encounter when interacting with large language models. And I think we should. I think, we have this really important role to play at helping the public make sense of what is going on with these models.
Amazing. Thank you so much. I mean, I think that's a beautiful point to end on, which is sort of what is our responsibility? How do we pursue this research in a way that makes these models safer, that still teaches us something about humans, about cognition? Sort of what are our responsibilities as researchers? I think that's fantastic, and a great note to close on. So with that, I want to thank all of our amazing speakers for coming out and first of all, recording all of their talks, giving their presentations, and now having this wonderful discussion on the panel. Big shout out as well to Matt, Bill, and Tom for organizing the workshop, and a big thank you to all of our attendees at the workshop and now at this virtual town hall. Thank you all so much. Last administrative thing just to say is that we will release the recording of this panel also on the website CogSci-LLM.com. Maybe Matt, if you want to paste it, the link, or actually here I have the link. So it'll be posted up there on our YouTube channel and on the website, along with the speakers' bios, so you can see who spoke here, see what they recorded previously, maybe reach out to them if you want to collaborate and talk to them, and if the speakers may reach back out to you as well. Yeah. So with that, thank you all so much. That's our town hall.
Thank you.
Thank you all.
Thank you, everyone.